So Julia wins the prize. Cyclops couldn't see eye to eye is a good one as well, but it was because the Cyclops only had one pupil, and I hope that's really bad. Barry Sulemana says, now I understand, with I spelled EYE. All right. Welcome. I think I pointed out my office last time. It's pretty much right behind my head. If we were on campus and if it were still summertime, it would look a lot like this, although I wouldn't be standing, 30 feet in the air or something. We have a few things for housekeeping today. We do have a makeup exam scheduled for tomorrow. It's Friday, November 6th at 5:30. If you need to take it and you haven't heard from Cheyenne, please contact her as soon as possible. We won't be offering another makeup. This is the one. So please contact her and make sure that she has your name and that she sends you the material you need. If you're still waiting on an excused absence from student experience or student success, whatever department it is that sends out those excused absences, please contact her anyway. What we will do is we will run you through the test, and if we need an excused absence, we just won't grade you or we won't give you a grade until that's actually done. The grading is going apparently very slowly. I'm not sure exactly what's holding it up, but we don't have the grading done just yet, so I can't really give you anything until Monday, I guess, at the earliest. We may have, if we have an update over the weekend, I'll post it out, but I won't be able to talk about it, obviously. Homework 6 is due tonight, so please, work on that, get it out. I've been answering a few questions on that one. Make sure you're using sets in homework 6. I'm going to go over a little bit today on how not to use dictionaries and sets, mainly because I'm seeing some of these bad patterns in some of the student work that I've been looking at on homework 6. So I want to make sure that everybody understands when you're using the set, when it's efficient and when it's not efficient, and the same with kind of dictionaries. Any questions before I get started? Let me makeup for exam 2. Yes. You can, let's see, you shouldn't, I think we're actually checking to make sure you use sets. I know that when we're talking about the stop words, you need to use a set for that. If you find a way to use a dictionary elsewhere in the problem, that's fine, but you must at least use a set to hold the stop words. That's explicitly called out in homework 6. So so you need at least to use a set for that part of it. If you find dictionaries elsewhere, and by the way, we're going to talk about using dictionaries with integers as keys being a lot like lists in just a few seconds. So that's actually a very valid comment going by. All right, let's take a look at a few things with not using sets. This is, if you think back a couple of lectures when we were doing sets, right? We had let's see, we started out with we wanted to find out how many. This is in the Wayback Machine. This was the code in the code developed in class section on how to figure out how many people there are, unique people there are in a file. So if we give this hanks.txt, we find out that there are 13 different people in the hanks.txt file. And all this is it's just a simple loop. It reads every line of the file one line at a time. It splits it according to the pipe symbol. Right, you remember this is our IMDb file. We've been working with these for quite some time. Let me pull one of these up. Right, it just looks like this. It has a person's name, has some white space. It has a pipe symbol, the vertical bar. It has the name of a movie, has some white space, and then it has the year the movie came out. So we had developed some code using a list to go through and check this. And the list, it just reads every line in the file, breaks it up into name, title, year, takes the name. This is the good one. Takes the name, checks to see whether the name's already in our name list. If it isn't, it appends it. If it is, it just skips it. And we had this set up so that it kind of prints out as it goes along, so we could see how fast it took and how much it slowed down. And then we had some instrumentation to tell us how long it took to run and how many different people we found. And this worked pretty well on something like Hank's, where we only had, I think, 60-some lines in the file. Works good there. But as we get into IMDb data, where we had 260,000, what we found out was the first couple thousand were fast, but as our number of items, right, this is how many lines we've looked at, this is how many unique names we found. As the number of unique names gets larger and larger, these loops start slowing down. We said that was an inefficient implementation, and we ran this for a while, and we chatted, and we did some other things, and eventually I killed it. I'm going to kill it again. And then we came out and we identified another way to do this using sets. And this time, this back to the list one, right? We decided that the slow part of this was this line number 27, where this innocuous looking name in name list is actually a for loop. You have to walk through the entirety of name list looking to see whether an entry in name list actually matches the name we're looking for, right? So this is a very long, this one line of code hides a very long operation or a potentially long operation as our list sizes get bigger. So we said, okay, let's do something different. Let's take a set, right? So instead of creating a list, we create a set. And we said, if we have a set, well, there are two ways to do this. We could do if name in, if not name in name set. Right, we could say if not name in name set, do the add. And we discussed this. We decided that this wasn't actually, line 27 wasn't actually needed because name set itself will only add something that's unique. It won't maintain multiple copies of the same thing. So, if name already exists, this is essentially does nothing. So we decided that we didn't actually have to do this, but let's put it back in for now just to kind of give us something to compare with. And we can run this, and what we can see is that hanks.txt is incredibly fast still, right? It's still finding 13 different people. But even as we get up onto IMDb data.txt, it's still a very fast one. And we decided that this was really fast because this operation, and this operation are very fast operations. They don't actually have to walk through the entirety of name set to decide whether name is in there. We talked about a hash function a little bit. I told you that you'd get more of it in data structures. But what I said was that a hash function maps this to a specific location in name set. So checking it is really very fast. You calculate where it's supposed to be. You look to see if it's there. And if it's there, well, then you don't add it. And if it's not there, then you add it. Every time you see the same name, every time you see Hank's Tom, it maps to the same location. And we can thus make this check instead of having an embedded for loop. It's really just a constant time operation. It's very fast and very quick. This is the right way to use sets. And in fact, this is, like I said, we don't even have to actually have this line in here. It doesn't hurt us to just do this. That's absolutely fine. And we can do this again. We can say IMDb data.txt And we get the exact same answer, 120,705 people. All right, so this is the fast way, and this is the right way to use sets. You don't iterate through the members. You just ask the question, is this already there? Well, just because you're using a set doesn't make things always fast. So let's look at this a little bit. Let's directly migrate this list code. I told you that this is an embedded for loop, so we could write this for name in name list, right? We could make the for, I guess I'll call this exist. In name list, if name is equal to exist, we'll break. So if we find it there, we're not going to add it again. We'll just break, get out of this for loop. No, that's not going to do it. We'll set a variable. And then we'll break. And then we can just say, if not found, oops, shoot. And I guess the only thing we have to do up here is we have to say found equals false. All right, so now every time we read a name, we're saying we haven't found it yet. We'll walk through. If we find it, we're going to mark found true. We're going to break just to get out of that loop. And then if we don't find it, we'll append it. That should work, I think, unless I made a mistake. Let's do it with hanks.text first. Just to test. Yeah, 13 different people. Okay. So this is actually equivalent to the first thing we had here where we were doing if name in name list. This is actually just making the loop explicit. And slow. All right. So why did I want to do that? I wanted to do that to show you some bad ways of using sets. And I got to do the same thing here. All right, so now we've just taken this nice set code, right? And what we've said is, well, if we had our if not name in name set, right? And we decided that we wanted to make this explicit, and we wanted to make it explicit, and then by putting it in a for loop, well, it would look something like this. And now the issue is this is explicitly walking through all of the names in name set. So when we actually run this, what we're going to find out is, let's make sure that I didn't mess it up, hanks.text found 13 different people. What we're going to find out is we've now ruined the whole use of the set because this is no longer... imdb data.text. Because this is no longer a fast operation. We're actually explicitly walking through every element of the set. So just because we're using a set doesn't actually make this fast. We have to use a set correctly, and we have to use the hashing operations to test membership. So this doesn't work. And there's a whole bunch of ways that this doesn't work. For example, this would be back to working. Don't know why I have that there. Just forgot to delete that. Right? That's working really fast. But what happens if we throw a sorted on here? Right? Sorted makes sure that our set comes back in sorted order. But it also, in order to do that, it has to convert it to a list. And as soon as it does that, walking through the list requires that we visit this name not in, requires that we visit every element of the list to make that decision. Right? So just throwing that sorted in there turns this from a set operation into a list operation, and means that this now takes a lot longer. This was equivalent, by the way, but I figured that I should have it consistent. This name in sorted, right? Sorted name set is a list. So checking for membership means you have to go through and visit all the values. Or at least until you find it. You have to, worst case, you have to walk through all the values. The same thing happens with our dictionaries. So you remember here, this is the code from class. Yes, last week, Monday, what we did was we wanted to find out how many movies everybody starred in, and we just did this by creating a list of lists. On the inner list, the nested list, the first element is the name of the actor, and the second element is how many movies they appeared in. And we said using a list works really well for hanks.txt, where there's only 63 entries. We got through that pretty fast. But we said we'd run into the same issue here. As our list of lists becomes longer and longer, this becomes a much longer operation. We can't use, we have to explicitly do this as a we can't use the membership. We can't say for if t in count list. We have to actually go through and do the checking ourselves this time. This construct you should be familiar with. And we said that as we come through and look at imdb data.txt, well, it's going to get slower and slower and slower. And we also showed that we could do something similar to that. Do I have a bad dictionary? Yes. Okay. So just like we used a set to fix the first problem, the first time, just counting the unique people, we decided that we could use a dictionary this time, and all we did was we created a dictionary, and instead of having to march through, we can just ask if the key, if the name we're looking for is in the counts. If it is, we increment it by 1. If it's not, we set it to 1, right? So this is just an association between Hank's Tom, for example, and a value that represents the number of movies he's been in. And we found out that this, works really. I'm not even going to do it on Hank's. This works really fast, right? Because, again, this doesn't have to walk through. Keys is a set. This doesn't have to walk through all of the elements of keys to make the determination, is this in the set? But again, if we're not careful, if, for example, we want to access our keys in sorted order for some reason, and we put in like a sorted call, or we convert keys to a list, or we do a for loop on counts.keys, that turns this quick operation of finding out whether something's in there into a very slow operation. Okay, and now again, we are taking longer and longer, more and more time. So, in this particular case, the difference is just this. We take that out, we get exactly the same answer. But it's as fast as it can print to the screen. Essentially, almost all the time here is just printing to the screen. Okay, so I just wanted to point that out. I was seeing some instances where you guys were sorting sets or possibly sorting probably not dictionaries yet. I don't think I saw any dictionaries, but it's the same kind of idea. We need to be very careful when we use sets and dictionaries to make sure that we don't convert them into an inefficient data form just by the way we use them. Make sure you use the operations that are defined on them. That's one of the reasons we made you go through so many of the string functions, was just so that you got used to using the operations that are defined on the specific data types, so that when we get into things like containers like dictionaries and sets, you're kind of used to that, and we can count on you actually doing this quickly and efficiently. All right, any questions on this? Let's see. All right, I'm not actually seeing too much here, and I think Kristen, our recorder, is she has a test today at this time, in fact. So the one question is about the makeup exam. If you have it, we need an excused absence to take the makeup exam. You can't just you just can't take it, unfortunately. So you do need to have an excused absence, or something bad had to have happened in order to be able to take the makeup exam. We just can't let you take. If I forced the TAs to grade everybody's exam twice, they would probably kill me. There would be an uprising, peasants, pitchforks. Stake through the heart. I'd be a vampire or something. All right, let's get on with our day. Actually, before I get on with our day, let me throw up this so that I have a little blocker